Hello, this is Ms. DB, and in this lesson we are going to continue working on Chapter 4, Section 3, using matrices to transform geometric figures. This video is going to be about how to do a dilation. That's a transformation that either enlarges or reduces the pre-image. Remember, the pre-image is the original, and the result will be similar figures, not congruent figures, but similar. If it's a similar figure, the shape is the same, the angles are the same, but the size may be different. Side lengths will be proportional. With this, when the center of dilation is the origin, that's what we're going to be working with, then multiplying the coordinate matrix by a scalar gives the coordinates of the dilated image. So we're just going to use origin as the center of dilation. In this first example, we're going to take a triangle, ABC, and with given coordinates, A, B, and C, and we're going to enlarge it by a factor of 2. So what we need to do is we need to write the pre-image matrix, which is this one. Remember that the x coordinates are the top row and the y coordinates are the bottom row. This would be A, this would be B, this would be C. So the coordinates of A is 2, 3, B is 1, negative 2, C is negative 3, 1. To enlarge by a factor of 2, we multiply this matrix by the scalar 2, which means that we multiply every entry by 2. And the result, this would be our image matrix. And this would be A prime, B prime, C prime. So A prime will be 4, 6, B prime will be 2, negative 4, and C prime will be negative 6, 2. And a graph of it shows that our pre-image was the blue, the smaller one, and then after an enlargement, it is that larger purple triangle that is around it. And here's the coordinates that you would write as part of the answer of the image. Here's some examples from your worksheet. It says that we have a triangle JKL at J, negative 3, 1, it's already graphed, K, 2, 2, and L, 1, negative 2. So that's already been graphed. Our directions are to use a matrix to transform this in the ways given in 6 and 7. So first, number 6 says to dilate or enlarge the figure by a factor of 3. So in this first matrix, we need to put our pre-image matrix. So this is going to be J coordinates, K coordinates, and L coordinates. X goes on top, negative 3, and the Y goes on the bottom. And then we need K was 2, 2, and L was 1, negative 2. And we are going to transform this by dilating, or by multiplying by a scalar. We want it actually to enlarge by a factor of 3. If it's greater than 1, it'll be an enlargement. So we are going to multiply every entry on here by 3. And when you do that, you'll get negative 9, 3 times negative 3. 3 times 2 is 6. 3 times 1 is 3. And then 3 times 1 is 3. 3 times 2 is 6. 3 times negative 2 is negative 6. It doesn't say that you have to graph. It would be hard to graph this one because negative 9 is not on my graph. It'd be over here somewhere. But you can tell it would be quite a bit bigger if I'm going to stretch it that far. However, you are supposed to write the coordinates. So we will now write that J, this is J prime, K prime, L prime. So then type that J prime is equal to negative 9, 3. K prime will be 6, 6. And L prime will be 3, negative 6. Now for number 7, it says to dilate, reduce the same figure by a factor of 0.25. So we're going to multiply every entry in the pre-image by 0.25. So this is going to result in a smaller triangle when we're done. This will stay the same, our JKL, our pre-image matrix. And then you will multiply each of these by 0.25. And when you do that, you will get decimals, or you could use 1/4. So 3 times 0.25, or 1/4 times negative 3 is going to be negative 3/4 or negative 0.75. It might be too hard for me to get all that in here. And then 0.25 times 1 is 0.25. So the coordinate, oh, I should have changed my color here. The coordinate of J prime will be negative 0.75, 0.25. I could graph that. You don't have to for this assignment. It's going to be tricky to get the little, maybe about right here. It's kind of hard to be accurate here. But you can see that it's going to be a much smaller triangle inside of here. So you can finish this up. So when you either enlarge or dilate, all you do is multiply by a scalar. At the end of this worksheet, you're going to combine what you've learned so far with translating or dilating, enlarging. And we are going to take this larger figure. This is a 1, 2, 3, 4, 5, a pentagon, a 5-sided polygon, and these are the coordinates. And we are going to first translate it, and then we are going to reduce it. So the translation matrix, you're going to put D, E, F, G, H. You'll put your coordinates in here. So remember, the x coordinates go at the top and the y coordinates go at the bottom. So you fill this in. 1, negative 1, negative 3, negative 2, and negative 2, 2. And then we will use our translation matrix to go 9 units left. So all of our x coordinates will be negative 9 all the way across, and 4 units up. So you'll fill the 4 in all the way across here, and the negative 9 across. And then you will add to get our image matrix, D prime, E prime, F prime, G prime, H prime. And you're not required to graph it, but you can. You would have to use, you wouldn't be able to graph it on this same coordinate system. You'd have to use Sketchpad or your own paper, because to go 9 units left, this whole like G is going to be over here somewhere. You're not going to be able to see it on your paper, and then up 4 units. So you can just list the coordinates of each of them. So D prime, I'll just do D. 1 plus negative 9 would be negative 8. 3 plus 4 would be 7. So D prime coordinate would be negative 8, 4. And then you can do the same thing to find E prime, F prime, G prime, H prime, and that's it. In the second part of this, you're going to take this exact same pre-image matrix. It'll be exactly the same. And you are going to multiply every part of that. The scalar is what? 0.1. So each of these coordinates will be multiplied by 0.1, and then your image matrix after that reduction will be over here. And then your coordinates you can list will be, let's see, this one will be 0.1 and 0.3. And you can do the same thing for each of them. All right, so that will be it for that worksheet. Thank you very much. And in the next one, we'll talk about how to do reflections and then rotations. Thank you very much. Have a great day.